The solar wind carries a constant stream of charged particles across the vast reaches of space. This invisible tide occasionally surges into a massive superstorm that interacts with our planet's magnetic shield. Scientists at global observatories noticed a strange resonance within the atmosphere during the last major event. The magnetosphere usually vibrates at predictable frequencies, but this time it produced a completely different pattern. Data suggests that the Earth might be responding to these cosmic forces in ways previously misunderstood. High-altitude satellites recorded a series of dense thermal anomalies rising from the deep crustal layers. Geologists believe these signals indicate a structural coupling between the core and the external space environment. Such interactions imply that our world is far more sensitive to the sun than once thought. Every layer of the planet seems to participate in a silent dialogue with the surrounding vacuum. You might feel the weight of this knowledge as you contemplate the scale of these forces. The atmosphere acts as a thin veil, protecting us from the harsh reality of the void. Beneath your feet, the ground remains stable, while the heavens above are churning with invisible energy. Researchers are now looking at historical records to see if this has happened many times before. Understanding this connection requires us to look beyond the surface and into the very deep interior. We are standing on a spinning sphere that is constantly bathed in a sea of radiation. The silence of the night masks a complex mechanical process that sustains life on this rock. Our journey through the cosmos is defined by these quiet rhythms of pressure and magnetic flow. This realization brings a sense of calm as we drift further into the heart of space. Ancient magnetic pathways connect the heart of our sun to the molten center of our world. Let your mind settle as we explore the invisible threads that bind the Earth to stars. If you enjoy these deep explorations in space, consider subscribing or hitting the like button. It really helps the channel grow and allows me to make content like this. The steady pulse of the sun remains a constant companion through the dark and silent reaches. We watch the northern lights dance while the magnetic field absorbs the impact of the storm. Your perspective shifts as you realize the delicate balance required to maintain life on this planet. We will continue to monitor the whispers of the universe from our small and fragile home. The atmosphere of Earth is not a static shell, but a breathing, fluid boundary that reacts to the sun. When a superstorm arrives, it does not merely hit the planet, it flows around and through it. You can think of the magnetosphere as a vast, invisible bell that rings when struck by solar flares. Usually, the sound is a low hum, a background noise that defines the standard state of our world. However, recent observations have shown that during peak activity, the bell rings with a note that shouldn't be there. This discovery suggests a hidden layer of complexity in how the Earth's core translates energy from the sun. As you listen, consider the stillness of your current surroundings compared to that high-altitude turbulence. The air around you is heavy and cool, providing a sense of grounded security and physical peace. While the upper thermosphere expands and contracts, the room you are in remains perfectly still and quiet. This contrast is the beginning of our understanding of the superstorm and its hidden structural secrets. The planet is a system of nested spheres, each one influencing the next in a slow dance. We are moving from the familiar comfort of the surface into the strange mechanics of the heights. The atmosphere is not a singular blanket, but a series of delicate, overlapping veils that interact with the harsh radiation of the sun. Deep within the lower layers, where the air is thick enough to support life, the changes are subtle and often go unnoticed by the human senses. However, as we move upward, past the clouds and the paths of commercial aircraft, the environment becomes increasingly reactive to the solar wind. A superstorm is not a localized event, but a global resonance that shakes the very foundation of our planetary shielding. Scientists have observed that during these periods of high activity, the upper atmosphere does not just heat up, it expands outward like a giant, slow-moving lung. This expansion is a physical response to the influx of energy from a distant star, a mechanical movement on a planetary scale. To understand the scale of this movement, imagine the Earth as a solid core surrounded by a fluid, shimmering ghost. This ghost is the air we breathe, the sky we see, and the shield that protects our delicate biological structures. When the Sun releases a coronal mass ejection, it sends 1 billion tons of plasma hurtling toward our small, blue oasis. This plasma is governed by magnetic forces that are far stronger than the gravity we feel on the surface. As this energy arrives, it encounters the magnetosphere, the first line of defense in our world's complex security system. The disturbing discovery made by researchers involves the way this energy doesn't just bounce off the shield, but actually penetrates deep into the lower registers of the sky. The term superstorm suggests a chaotic event, but to a scientist, it is a highly structured transfer of power. It is a moment where the invisible boundaries between space and Earth become porous and interconnected in ways that challenge our traditional models. We used to believe that the weather of the surface and the weather of space were two entirely separate systems with very little overlap. Now, data from high-altitude sensors suggests that a significant storm in the magnetosphere can trigger a vibrational response in the Earth's crust. This means that the ground beneath you is subtly tied to the explosions occurring on the surface of the Sun, millions of miles away. It is a quiet, profound connection that underscores the unity of our entire solar neighborhood. As we drift further into this concept, consider the density of the air around your body right now. This air is composed of molecules that have been recycled through the lungs of every living creature for millions of years. It is a stable, reliable medium that carries sound, provides oxygen, and buffers the temperature of the world. In the heights of the thermosphere, the air is so thin that it would be considered a vacuum by most laboratory standards. Yet, even in this near emptiness, there is enough matter to catch the solar wind and translate its fury into a soft, glowing light. This is the duality of our world. It is both incredibly robust and remarkably sensitive to the touch of the stars. The process of discovery begins with the realization that the Earth is a participant in a much larger mechanical dialogue. Every time a superstorm hits, the planet rings like a bell, producing a series of low-frequency waves called Schumann resonances. These waves travel around the circumference of the globe, trapped between the surface and the ionosphere. Recent studies indicate that these resonances changed their fundamental pitch during the last major solar event, shifting into a minor key. This shift was the first clue that the superstorm was affecting the internal structure of the planet's electromagnetic field. It was as if the Earth itself was reacting to the pressure by tightening its internal coils. Imagine the planet as a complex clockwork mechanism, where every gear is connected by invisible magnetic teeth. When the solar wind pushes on the outer gears, the movement is transmitted down through the layers until it reaches the very center. The core of the Earth is a spinning ball of molten iron, generating the magnetic field that allows us to exist in peace. The superstorm reveals that this core is not isolated, but is actively being fed or tousled by the activity of the Sun. This feedback loop is what makes the recent findings so intriguing to the scientific community. It suggests that the Earth is not just sitting in space, it is dynamically integrated into the solar system's energy grid. As you continue to relax, let the idea of this scale wash over you like a slow-moving tide. You are currently resting on the surface of a giant magnet that is wandering through a stream of charged particles. The disturbing element is simply the realization of how much we have yet to learn about our own home. We are like passengers on a vast ship who have just discovered that the engines are connected to the movements of the ocean itself. This realization doesn't diminish our safety. It enhances our appreciation for the complexity of the vessel that carries us. The peace you feel now is a direct result of these massive silent systems working in perfect harmony to maintain the status quo. The transition from the surface to the edge of space is a journey of decreasing density and increasing mystery. At sea level, the air is a heavy blanket. At the edge of the atmosphere, it is a whisper, yet it is this whisper that decides the fate of our technology, our power grids, and our understanding of physics. When the superstorm arrives, the whisper becomes a shout, echoing through the vacuum and vibrating through the iron heart of the world. Researchers are currently mapping these vibrations, looking for patterns that might predict the next great expansion of the thermosphere. They use satellites that drift like dandelion seeds in the upper reaches, tasting the solar wind as it passes by. We move now from the general observation of the storm to the specific way it interacts with the human-scale world. This involves looking at the history of our planet and how it has weathered these cosmic events for eons. The Earth is an ancient witness to the Sun's moods, and its geological layers hold the record of every major storm. By studying these layers, we find evidence of times when the sky was filled with fire and the compass needles spun in circles. These events are rare, occurring perhaps once every few centuries, but they are a fundamental part of our world's long-term rhythm. We are currently in a period of quiet study, waiting for the next data point to emerge from the darkness. This brings us to the realization that the revealed secret of the superstorm is one of interconnectivity. The planet is not a closed system, it is an open book, being written by the light and particles of the Sun. Every breath you take is possible because of the magnetic field's strength and the atmosphere's resilience during these storms. The stillness of your room is a testament to the effectiveness of these cosmic shields. As we explore the deeper layers of this topic, remember that the mystery is not a source of fear, but a source of wonder. It is the quiet unfolding story of a planet that is far more alive and responsive than we ever dared to imagine. The soft hum of the universe is always there, if you know how to listen for it with the right instruments. In the absence of loud noises and distractions, we can begin to sense the subtle pressure of the solar wind on the edge of our world. It is a gentle, persistent force that shapes the very path of our evolution and our future among the stars. We are drifting now into a deeper understanding of these mechanics, letting the complexity of the science soothe the mind into a state of calm curiosity. The journey is long, the scales are vast, and the peace of the discovery is absolute. To understand the thickness of the atmosphere, imagine you are taking a long afternoon walk uphill. If you could walk straight up for about 20 miles, you would pass most of the air. This distance is shorter than a marathon, a length a person could traverse in a single day. Yet, within that small vertical span, the entire drama of terrestrial life is contained and safely held. The shield that protects us is thinner than the skin of an apple relative to its size. It is a delicate, translucent membrane that keeps the cold vacuum of the universe at a distance. When we talk about a superstorm, we are talking about a gust of wind in space. Think of a gentle breeze blowing across a field of tall grass, causing it to ripple. On a cosmic scale, the Earth is that blade of grass, and the solar wind is the breeze. The disturbing element found by researchers is not a threat, but a shift in our perspective. It is the realization that the grass is connected to the Earth by much deeper roots than expected. The ripples do not just stay on the surface, they vibrate down into the dark, heavy soil. To grasp the magnitude of these celestial mechanics, we must first bring them down to the level of a human life, a human stride, and the objects we touch every day. Consider the distance of the atmosphere once more. If you were to set out on a brisk walk, moving at a steady pace through a quiet forest, you would cover about 3 miles in an hour. In just 10 hours of walking the length of a long summer day, you would have traversed the equivalent height of the entire breathable atmosphere. This thinness is a comforting thought. It suggests that our world is compact, intimate, and held closely by gravity. We are not lost in an infinite fog. We are nestled within a specific, measurable boundary. However, the superstorm changes how we perceive this boundary. Imagine you are standing in a large, open plaza. The ground is paved with heavy stone, and the air is still. Suddenly, a distant vibration begins, a low frequency that you feel in the soles of your feet before you hear it with your ears. This is how a superstorm interacts with the Earth. It does not simply blow past us, it couples with the planet. Scientists have found that the energy from these solar events travels down the magnetic field lines, which act like massive, invisible harp strings. When the solar wind plucks these strings at the edge of space, the vibration travels all the way down into the bedrock. This connection means that the deep, silent interior of our world is in a constant, subtle conversation with the sun. Think of an old grandfather clock standing in a quiet hallway. The pendulum swings back and forth with a rhythmic, mechanical certainty. You might assume the clock is a closed system, ticking away in its wooden case. But if a heavy truck drives past the house, the slight tremor in the earth can subtly alter the swing of that pendulum. The superstorm is that passing truck, and the Earth's core is the pendulum. The disturbing revelation is that our planet's internal clock, the rotation of its core, and the flow of its mantle is sensitive to the weather of the deep cosmos. This makes the Earth feel less like a lonely rock and more like a sensitive instrument, tuned to the frequency of its star. The scale of the energy involved is often described in numbers so large they lose their meaning. We hear of terawatts and exajoules, units that exceed our daily experience. To make it human, imagine every person on Earth, all 8 billion of us, each holding 1,000 bright flashlights. If we all turned them on at once and pointed them at a single point in the sky, we would still not match the energy delivered to the upper atmosphere during a single minute of a solar superstorm. Yet, despite this overwhelming power, the transition is so smooth and the shielding so effective that you can sit in your room in total silence and feel absolutely nothing. The chaos of the sun is translated into the peace of your evening through the sophisticated machinery of the planetary fields. Historically, we viewed the Earth as a series of separate compartments: the core, the mantle, the crust, the ocean, and the air. We lived in the air and walked on the crust, rarely thinking of the fire beneath or the vacuum above. But the superstorm has revealed that these compartments are joined by a magnetic elevator. This elevator carries energy from the height of 100,000 miles down to the very floor of the Atlantic Ocean. It is a slow, grounding process. When you submerge your hand in a cool basin of water, you feel the immediate pressure and temperature. The Earth feels the superstorm in a similar way, a slow, pressurized change that ripples through its various states of matter. Consider the objects in your room: a wooden table, a ceramic mug, the fabric of a blanket. These things feel solid and disconnected from the void of space. But the atoms within them are governed by the same electromagnetic forces that are currently being buffeted by the solar wind. There is a gentle humor in our insistence on being grounded. We walk on the Earth to feel stable, yet the Earth itself is a vessel sailing through a hurricane of light. Our sense of stability is a gift provided by the sheer mass of the planet. It takes a tremendous amount of energy to move a sphere made of 6 sextillion tons of rock, and so we feel only the stillness, even when the cosmic environment is screaming. The researchers who study these events are like librarians, cataloguing the whispers of a giant. They use magnetometers buried in the ice of Antarctica and sensors floating in the dark of the Pacific. What they found during the last great storm was a long-period resonance. This is a fancy way of saying that the Earth began to hum a very deep, very slow note. This note lasted for days, a lingering echo of the sun's touch. It wasn't a sound you could hear, but a shift in the magnetic background that every compass on the planet felt. It reminds us that we are part of a larger body, a planetary organism that has its own ways of feeling and responding to its environment. As we move through this section, let the scale of these thoughts settle. You are a small, precious observer on a very large, very sensitive world. The disturbing discovery is simply a reminder of our intimacy with the universe. We are not separate from space. We are a part of it, connected by invisible threads of force that reach into the very center of our being. The roots of the grass go deep, and the wind from the stars is just another part of the garden's natural cycle. The planet is breathing, the core is spinning, and you are safe within the layers of this magnificent, complex home. The realization that the Earth is coupled to the sun changes how we think about time as well. A human life is roughly 80 years. In that time, the sun will go through 7 of its major cycles. To us, a superstorm is a once-in-a-lifetime event. To the Earth, which has existed for 4.5 billion years, these storms are as frequent as heartbeats. The planet has been disturbed by the sun millions of times, and each time it has absorbed the energy, vibrated the note, and returned to its steady, silent path. This continuity is the ultimate source of calm. The system is designed to handle the scale. It is built to survive the storm. We are now drifting toward the idea of scale expansion. We have seen how the storm feels like a breeze and how the Earth feels like a blade of grass. We have felt the vibration in the stones and heard the slow hum of the magnetic harp. This understanding prepares us to look even further out, beyond the immediate vicinity of our world, into the vast structures that the Earth builds in its wake as it travels through the dark. The journey continues, moving from the human stride to the orbital path, always grounded in the quiet, steady reality of the scientific truth. Everything you see around you is a part of this story. The light in your room, the air in your lungs, and the ground beneath your feet. They are all participants in the grand, slow dance of the nested spheres. As we transition to the next stage of our exploration, keep that sense of grounded peace with you. The mystery is large, but the world is solid, and the story of the Superstorm is simply the story of how our home stays connected to the light that gives it life. Now let us move outward to the magnetopause, where the Earth's magnetic field meets the Sun's power. Here, the solar wind is traveling at speeds of nearly 1,000,000 miles per hour as it hits. The collision creates a shock wave, similar to the water piling up at the bow of a ship. Astronomers have long mapped this region, believing it to be a simple shield of magnetic force lines. But during the most recent superstorm, they found cracks that allowed plasma to leak straight through. This leakage created a bridge of energy that reached down toward the poles in a direct circuit. Instead of being deflected, a portion of the storm was invited inside the planet's primary defensive perimeter. We understand that these reconnections happen, but the scale of this specific event was quite unprecedented. There is a mild mystery in why the field opened so widely and stayed open for so long. We accept this uncertainty, knowing that the magnetic field is a living, shifting thing that we monitor. This brings us to a larger scale, where we look at the entire orbital path of Earth. To understand this bridge, we must look at the process of magnetic reconnection. Imagine two streams of water flowing in opposite directions that suddenly snap and merge into a single, powerful torrent. In the vacuum above our heads, the magnetic field lines of the Sun and the Earth do exactly this. They break and reform, creating a literal doorway where there was once a wall. During the superstorm, these doors did not just flicker open, they stayed wide, allowing a massive influx of solar plasma to pour into the upper atmosphere. Scientists call this a flux transfer event, but for us, it is a reminder that even the most solid-seeming defenses in nature have a certain fluidity. The disturbing aspect, discovered by researchers, was the duration of this opening. Normally, the Earth's magnetic field is resilient, snapping back into place like a rubber band. However, during this event, the field remained in a state of open connectivity for hours longer than our models predicted. It suggests that the Earth was not just being hit by the storm, but was actively absorbing it, integrating the solar energy into its own electromagnetic system. This brings a sense of quiet awe to the study of our planet. We are not just a rock in a stream, we are a sponge in an ocean, occasionally soaking up the very essence of the star we orbit. As we move outward, we see that this connection extends far beyond the atmosphere. The Earth moves along its orbital path at 67,000 miles per hour. This is a speed that is difficult to visualize, yet we feel no wind, no vibration, and no sense of movement. We are traveling through a near vacuum, but that vacuum is filled with the interplanetary magnetic field. This field is a sprawling, invisible web woven by the Sun, stretching across the entire solar system. Every second of every day, the Earth is plowing through this web, and the superstorm is a moment where the web becomes tangled and dense. Consider the scale of the magnetotail. This is the part of the Earth's magnetic field that is blown back by the solar wind, stretching out like the tail of a comet. It reaches far past the orbit of the Moon, extending millions of miles into the dark. During the Superstorm, researchers noticed that this tail was not just stretching, it was pinching off and releasing massive bursts of energy back toward the Earth. This process, known as a substorm, is a repetitive cycle of tension and release. The tail builds up energy like a drawn bowstring, and then, in a moment of cosmic realignment, it snaps. There is a mild mystery in the snap. We know it happens, but we cannot yet predict exactly when the tension will become too much for the field to hold. We watch the satellites, we monitor the particle counts, and we wait. There is a calm acceptance in this waiting. It is the same feeling one might have watching the tide come in on a quiet beach. You know the water will rise, and you know it will eventually recede. The superstorm is just a higher tide, a moment where the ocean of space reaches a bit further up the shore than usual. To understand this further, we step back even more, looking at the Earth as a small blue dot in a massive electromagnetic sea. The bridge of energy that researchers found is a sign that the dot and the sea are more deeply connected than we previously assumed. The Earth's interior, the churning iron core, is linked to the Sun's corona through a series of complex, invisible circuits. When the Sun flares, the Earth responds. It is a dialogue that has been going on for billions of years, a conversation in the language of physics and light. Think of a large, old-growth forest. The trees seem separate, but beneath the soil, their roots are intertwined, sharing nutrients and information through a network of fungi. The solar system is much like this forest. The planets seem like isolated islands, but they are all connected through the magnetic fields and the solar wind. The superstorm is simply a season of high growth, a time when the nutrients of the sun are shared more aggressively with the planets. The disturbing discovery is just the realization of how deep those roots actually go. We are finding that the Earth's core might be modulated by these external forces, influencing everything from the strength of our shield to the movement of the tectonic plates. This brings us to a larger scale of time. If we look at the orbital path of the Earth over thousands of years, we see that these openings in the field are a regular part of our history. They have shaped the atmosphere and perhaps even influenced the evolution of life itself. The mystery of why the field stayed open is a puzzle for the next generation of scientists, but for us, it is a reason to feel a sense of belonging. We are not accidental tourists in a hostile void. We are part of a highly coordinated system that manages energy on a scale that is truly staggering. As the energy from the storm filters down, it eventually dissipates into heat in the thermosphere. This heat causes the atmosphere to puff up, increasing the drag on satellites and causing them to slowly descend. This is a physical, mechanical consequence of a magnetic event. It shows how the abstract world of fields and forces eventually touches the concrete world of metal and machines. The researchers who discovered this were looking at the orbital decay of small satellites, noticing that they were dropping faster than they should have. This disturbing drag was the footprint of the superstorm, the physical proof of the energy bridge. We accept this uncertainty calmly. We know that the sky is not a static ceiling, but a dynamic, changing frontier. The disturbing elements are merely the parts of the story we haven't finished reading yet. Each superstorm is a new page, a new set of data points that help us refine our understanding of the world. The bridge of energy is not a threat, it is a connection. It is the umbilical cord that ties our planet to its mother star, providing the energy and the protection we need to continue our slow journey through the dark. The scale of the expansion continues. We move from the magnetotail to the heliosphere, the giant bubble created by the sun that encompasses all the planets. Within this bubble, the Earth is a tiny vibrating particle, perfectly placed to sustain life. The superstorm is a ripple in the heliosphere, a wave that passes through our neighborhood and leaves us slightly changed. We watch the wave approach, we feel its impact, and we watch it move on toward the outer planets. There is a profound continuity in this movement, a sense that we are part of a much larger story than we can fully comprehend. As you drift further into the silence of the night, let the scale of the orbital path settle in your mind. You are moving through space at incredible speeds, protected by a living magnetic shield that occasionally opens its doors to the sun. The mystery of the open field is a quiet companion to your thoughts, a reminder that the universe is always more complex and more beautiful than we think. The energy is flowing, the field is shifting, and the planet is stable. We are moving smoothly from the scale of the orbit to the deep drift of the cosmic sea. The transitions are inevitable. The bridge of energy is just one part of the mechanical process that keeps the Earth in balance. By inviting a portion of the storm inside, the planet is able to regulate its own internal systems, shedding excess charge and maintaining its equilibrium. It is a self-regulating mechanism that has worked for eons. We are just the latest observers to notice the details of how it works. The mystery is not a void. It is a fullness of information that we are slowly, calmly beginning to decode. This brings us to a deeper phase of our journey, where the facts become less dense and the abstraction begins to take hold. We have seen the bridge, we have felt the drag, and we have understood the reconnection. Now, we simply exist in the knowledge of it. The scale is large, the mystery is mild, and the peace is absolute. We are ready to drift into the next section, where the rhythm of the repetition will guide us toward a state of total cosmic continuity. Moving further out, we see the Earth trailing a long magnetic tail behind it like a silk ribbon. This magnetotail stretches millions of miles into the dark, away from the sun's direct and piercing light. During a superstorm, this tail can snap and reconnect, flinging energy back toward the planet in a snap. It is a cosmic slingshot, recycling the sun's energy and sending it spiraling down into our own atmosphere. You can observe the result of this process in the dancing lights of the aurora at the poles. These lights are the visual signature of a planet that is deeply plugged into its local stellar neighborhood. The mystery lies in the timing of these snaps, which do not always follow the expected solar cycles. Some researchers suggest the Earth's core has its own rhythm that dictates when these gates will open. We do not yet have the instruments to peer deep enough into the molten center to confirm. We sit with this lack of knowledge, drifting comfortably in the realization that much remains to be found. To understand that, we need to step back and look at the history of these events. As we step back, we begin to see that the Earth is not a passive recipient of solar energy, but an active participant, with its own internal pulse. This pulse originates thousands of miles beneath your feet, in a realm of extreme pressure and liquid metal. The outer core, a sea of molten iron and nickel, is constantly churning, driven by the heat escaping from the solid inner core. This motion creates a dynamo effect, generating the massive magnetic field that stretches far out into the cold vacuum of space. We used to believe this dynamo was a steady, predictable engine, but recent data from the Superstorm suggests the core might have seasons of its own. These internal seasons could determine how the magnetic field reacts when the sun strikes it with a burst of plasma. Imagine a large, heavy door with a complex lock. The solar wind is the hand trying to turn the handle, but the Earth's core is the mechanism inside that decides if the bolt will slide or remain firm. During the most recent superstorm, the lock seemed to behave in a way that defied our previous mechanical models. The field opened at unexpected latitudes, allowing energy to seep into regions that are usually shielded. This suggests that the internal state of the core might be just as important as the intensity of the solar storm itself. It is a dual system, a partnership between the star and the planet, where both must be in a specific alignment for the disturbing bridge of energy to form. To understand the history of these events, we look at the quiet testimony of the rocks. Geologists can read the magnetic history of the Earth in the alignment of minerals within ancient lava flows. When lava cools, it locks in the direction and strength of the magnetic field at that exact moment in time. These fossilized magnetic records tell a story of a field that is constantly shifting, weakening, and sometimes even flipping entirely. Within these records, we find evidence of prehistoric superstorms that dwarf anything recorded in modern history. These were moments when the gates stayed open for centuries, potentially altering the chemical composition of the atmosphere and influencing the path of biological life. There is a calm certainty in this deep time perspective. The planet has weathered these events for billions of years, adapting and responding with a resilience that is difficult for us to fully comprehend. The disturbing discovery of today is merely a localized data point in a vast, ancient ledger. We are beginning to see that the Earth's core might vibrate in sympathy with the sun's cycles, or perhaps it possesses a frequency that is entirely its own. We accept this lack of clarity as a natural part of our scientific journey. We are like children listening to the faint ticking of a watch, trying to understand the gears inside without ever opening the case. To understand the density of a black hole, we might look at the objects in your own room. Imagine taking a common household item, like a heavy iron paperweight or a small ceramic cup. If you were to compress the entire Earth down to the size of a single marble, it would become a black hole. This comparison helps us visualize how much matter is packed into such an impossibly small, dark space. The gravity of such a marble would be just as strong as the Earth's current pull. However, you would have to be incredibly close to that marble to feel its true intensity. Think of the way a heavy bowling ball rests upon a soft, supportive mattress in your home. The fabric dips and curves around the weight, creating a gentle slope that pulls nearby objects in. This is much like how a black hole curves the fabric of space-time around its central point. If you were walking toward one at a human pace, the transition would feel very gradual. At a great distance, a black hole behaves just like any other mass in the quiet sky. It is only when you approach the edge that the nature of time begins to change. Imagine a clock sitting on a shelf, ticking away the seconds of a long, peaceful afternoon. As that clock moves closer to a source of extreme gravity, its ticking would appear to slow. To a distant observer, the hands of the clock would seem to move through honey, thick and viscous. Eventually, the movement would appear to stop entirely, frozen in a single, quiet moment of eternal rest. This slowing of time is not a trick of the light, but a physical reality. It reminds us that our perception of a steady now is tied to where we stand. In the presence of a giant, time stretches out like a long shadow at the end of the day. To understand the weight of such an object, think of a simple kitchen sponge. If you were to squeeze that sponge in your hand, it becomes smaller and denser, yet its mass remains the same. Now, imagine if you could squeeze the entire mass of a mountain into a single grain of sand. This grain would be so heavy that it would slip through your fingers, through the floor, and deep into the earth. A black hole is the ultimate version of this compression, where matter has folded inward until it occupies no space at all. We call this the singularity, a point where the familiar rules of our physical world simply pause. It is a quiet place where the math we use to describe the universe reaches a gentle, silent limit. Imagine walking along a shoreline where the sand is perfectly smooth and the water is still. As you walk toward the ocean, the slope of the beach becomes slightly more pronounced with every step. At first, you barely notice the change, but soon you find your pace slowing as the gravity of the water pulls at your feet. A black hole creates a similar slope in the fabric of the universe, a curve that directs everything toward its center. If you were to drop a small pebble into this curve, it would not fall straight down, but would spiral in a long, lazy circle. This movement is predictable and steady, a rhythmic descent into the heart of the dark. Think of a heavy velvet curtain hanging in a quiet, dimly lit theater. If you place a small lead weight into the folds of the fabric, the velvet stretches and sags under the pressure. This stretching represents the way a black hole distorts the dimensions of length, width, and height. To an observer standing far away, an object approaching the black hole would appear to stretch out like a piece of warm taffy. This process, which scientists sometimes call spaghettification, happens so slowly and smoothly that it feels like a natural extension of the space itself. There is no sudden jerk or snap, only a gradual lengthening into a thin, shimmering thread of light. In our daily lives, we think of a second as a fixed and unchangeable unit of measurement. We set our watches by it, and we feel its steady pulse in the beating of our own hearts. But near a black hole, the very concept of a second becomes fluid and soft, like wax melting in the sun. If you were to spend an hour near the edge of a massive black hole, years might pass for your friends back on Earth. When you returned, you would find the world moved on, while you remained essentially unchanged by the passage of time. This is the mystery of relativity, a gentle reminder that the universe does not keep a single, universal clock. Consider the way a magnifying glass bends the light from a nearby lamp to create a bright, focused point. A black hole acts as a cosmic lens, bending the light of distant stars that pass behind it. This creates a shimmering ring of light, a halo that glows with a steady and ancient brilliance. We call this an Einstein ring, a visual proof that gravity can warp the path of a photon. The light does not travel in a straight line, but follows the curve of the space-time that the black hole has shaped. It is a beautiful, silent distortion that allows us to see the invisible through the behavior of the visible. If you were to toss a letter into a campfire, the paper turns to ash, and the information written on it seems to vanish. Scientists have long wondered if the same thing happens when information falls into a black hole. Is the history of an object lost forever, or is it stored somehow on the surface of the event horizon? This is known as the information paradox, a quiet debate that has lasted for decades among the greatest minds in physics. We accept this uncertainty with a sense of calm curiosity, knowing that the answers may lie in a new understanding of reality. Perhaps the black hole is not a consumer of information, but a vast and silent library of everything it has ever touched. Imagine a large, spinning top moving across a wooden floor in a series of wide, graceful loops. As the top spins, it drags a small amount of the air around it, creating a tiny, invisible whirlpool. A rotating black hole does something similar to the space around it, a phenomenon known as frame dragging. It literally pulls the fabric of space and time along with it as it turns, twisting the universe into a gentle spiral. If you were floating nearby, you would find yourself being carried around the black hole even if you were standing perfectly still. It is a slow, rhythmic rotation that governs the movement of everything in the local neighborhood. The event horizon is often described as a point of no return, but it is better thought of as a transition. It is the boundary where the escape velocity required to leave exceeds the speed of light itself. Since nothing can travel faster than light, nothing that crosses this line can ever find its way back to the outside world. Yet, from the perspective of someone crossing the line, there might be no physical marker or sign at all. You would simply continue your drift, moving deeper into the shadows while the universe behind you begins to fade. It is a peaceful departure from the known, a movement into a realm where the future and the past become one. Think of the way a deep, wide river flows toward a distant waterfall in the mountains. Far upstream, the water moves slowly, and you can swim against the current with ease. But as you get closer to the edge, the flow becomes stronger and more insistent, pulling you toward the drop. The event horizon is like the very edge of that waterfall, the place where the current becomes absolute. To someone watching from the shore, you would appear to slow down as you reach the brink, eventually becoming a still image. But to you, the water remains calm, and the transition over the edge is just another part of the long, steady journey. In the silence of the vacuum, black holes are not truly black, but are often surrounded by the most energetic processes in the universe. Massive jets of particles can be shot out from the poles of a spinning black hole, traveling across millions of light years. These jets are powered by the immense gravitational energy of the material falling inward, twisted by magnetic fields into tight, glowing beams. They act as cosmic lighthouses, signaling the presence of a giant in the dark heart of a distant galaxy. Despite their power, these jets move with a consistent, unwavering, steady flow that spans across the deep time of the cosmos. We often imagine space as an empty void, but it is more like a physical material that can be stretched, twisted, and torn. A black hole is the place where this material is stretched to its absolute breaking point. Yet, even in this extreme state, there is a sense of order and mathematical beauty to the way it behaves. Every black hole can be described by just 3 simple properties: its mass, its spin, and its electric charge. This simplicity is a profound realization, suggesting that at the deepest levels, the universe is governed by very few rules. We find comfort in this simplicity as it allows us to map the infinite using the tools of human logic. As we conclude this exploration of the human scale, let your mind rest on the image of a single star orbiting a dark center. The star moves in a perfect, repeating ellipse, never faltering and never rushing its long journey. It is held in place by an invisible hand, a balance of motion and gravity that has lasted for billions of years. You are like that star, moving through your own life with a steady rhythm that is connected to the wider universe. The black holes are not monsters to be feared, but natural parts of a grand and ancient system. They are the anchors of the galaxy, the silent guardians of the deep, and the ultimate expression of nature's power. Now, as the scale begins to expand once more, we prepare to move outward into the wider reaches of the galactic neighborhood. The transitions are soft, like the fading light of a long summer evening as the stars begin to appear. We leave the familiar world of clocks and sponges behind, drifting toward the giant structures that shape the destiny of the cosmos. Every step is taken with a quiet breath, a slow movement toward the heart of the mystery. The universe is waiting for us, calm and vast, ready to reveal its secrets in its own patient time. To move outward, we must first look at the stellar mass black holes that pepper our own Milky Way like invisible weight-bearing pillars. These are the remnants of stars that were once 20 or 30 times the size of our Sun. When such a star exhausts its nuclear fuel, it can no longer support its own immense weight. It collapses in on itself, a process that happens with incredible speed but leaves behind a silence that lasts for billions of years. Imagine a grand cathedral made of light and glass, suddenly folding into a single microscopic point of lead. The structure is gone, but the presence of its weight remains, warping the air around it. As we drift away from the comfort of our solar system, we encounter the first of these dark neighbors. They are scattered throughout the spiral arms, often hidden within thick clouds of interstellar gas and dust. We know they are there because we see the gas being pulled toward them, spiraling inward like autumn leaves caught in a gentle backyard whirlpool. The gas heats up, emitting a soft X-ray glow that allows our telescopes to map the location of the invisible. It is a slow and rhythmic consumption, a steady transfer of matter from the visible world into the unseen depths of the singularity. Consider the relationship between a black hole and a companion star. In many cases, these dark objects are not alone. They dance with a living star in a tight, gravitational embrace. The black hole acts as a silent partner, slowly drawing a thin stream of plasma from the star's outer atmosphere. This stream forms a disk, the accretion disk that we discussed earlier. From a human perspective, this process is incredibly slow. It would take millions of human lifetimes for the black hole to finish its meal. This slow pace is a hallmark of the cosmos. There is no sense of urgency, only the inevitable and patient pull of gravity. As we move further out, the distances between these objects begin to grow. We leave the dense clusters of stars and enter the vast, cold spaces between the spiral arms. Here, the vacuum is almost perfect, yet it is still governed by the same laws of physics. Even in the emptiness, the presence of a distant black hole can be felt. It acts as a lens, subtly distorting the light of the galaxies that lie millions of light years beyond it. You might imagine space as a sheet of thin, clear ice. A black hole is a slight depression in that ice. a place where the surface curves just enough to change the path of a sliding stone. The movement through the galactic neighborhood is a movement through history. Every black hole we pass is a tombstone for a star that lived and died long before humans ever looked at the sky. They are the elders of the galaxy, the final state of matter that has seen the beginning of our world and will see its eventual end. There is a sense of safety in this permanence. The universe is not a chaotic place of random events. It is a structured environment where every ending is a new, stable beginning. The black hole is the most stable state of all, a place where change has reached its final, quiet conclusion. Think of the way a heavy snowfall muffles the sounds of a busy city, turning everything into a soft, white landscape of silence. The gravity of the galactic neighborhood acts in a similar way, smoothing out the fluctuations of the stars and creating a steady, rhythmic flow. As we drift, we notice the way the stars are organized into long, sweeping streams. These streams are guided by the overall mass of the galaxy, a mass that is anchored by the dark objects at its heart and scattered throughout its arms. You are a part of this flow, moving with the same grace and inevitability as the light itself. The transition from the human scale to the galactic scale requires us to let go of our traditional measurements of distance. We no longer speak in miles or kilometers, but in the time it takes for light to travel across the void. A light year is a distance so vast that it is difficult to visualize, yet it is the basic unit of our cosmic neighborhood. To move 1 light year is to step back in time by 1 year. As we move outward, we are looking further and further into the past, seeing the universe as it was when the light first began its long journey toward us. This is the beauty of the cosmic perspective. To look out is to look back, and to look back is to understand our origin. In the heart of these observations is a mild, unresolved mystery. Why do some stars become black holes, while others become neutron stars or white dwarfs? We know it has to do with the mass of the star's core, but the exact boundary, the limit of stability, is a subject of ongoing study. We accept this uncertainty, knowing that nature does not always provide sharp lines. There is a grey area where the matter is squeezed to the very brink of collapse, and it is in these liminal spaces that the most interesting physics occurs. We observe the pulsar, the magnetar, and the black hole, and we see them as part of a single, continuous spectrum of density. As we continue our drift, the scale expansion loops begin to overlap. We see the small black holes feeding on their companions, and we see the larger black holes anchoring the clusters. The patterns are the same, only the magnitude has changed. The same spiral motion, the same bending of light, and the same slowing of time occur at every level. This fractal nature of the universe is a source of great comfort. It suggests that if we can understand the small, we can begin to understand the large. We are scaling the heights of infinity by looking at the shadows in our own backyard. The galactic neighborhood is a place of deep drift and quiet contemplation. Here, the stars are like grains of sand, scattered on a dark velvet cloth. Each grain is a sun, and each sun has its own story, its own planets, and perhaps its own life. But from our perspective, they are all part of the same grand design. The black holes are the punctuation marks in this design, the places where the story takes a deep breath and pauses. They provide the contrast that makes the starlight so beautiful. Without the dark, we would not appreciate the light. Without the void, we would not appreciate the matter. Imagine the way a large ship leaves a wake in the water, a series of ripples that spread outward long after the ship has passed. A black hole moving through the galaxy leaves a similar wake in the distribution of stars. It pulls at the stars as it passes, subtly shifting their orbits and creating a trail of gravitational memory. We can map these wakes to find the black holes that are traveling alone, the rogue singularities that drift through the dark like silent nomads. They are the lone wanderers of the cosmos, carrying their secrets with them as they move from one arm of the galaxy to the next. As we prepare to step even further back, we take one last look at the stars of our neighborhood. They are bright, vibrant, and full of energy. But we know that beneath their light lies the potential for the dark. Every star is a future remnant, and every remnant is a testament to the endurance of the universe. We move outward now, leaving the familiar constellations behind and looking toward the vast, dark spaces between the galaxies. The transition is soft, a slow fading of the local light into the deep, ancient glow of the cosmic background. The universe is waiting, and we are ready to move deeper into the heart of the mystery. To understand the cosmos, we first have to understand our own limitations. We evolved to perceive distances we can walk in a day, or see with our own eyes distances that matter for survival and navigation. A kilometer is a 10-minute walk. A mile is a 20-minute journey. These measurements are concrete and relatable because they fit into our daily lives. But the moment we look up, these human-scaled units become awkward and eventually useless. To explore the universe, we must leave behind the familiar and prepare for a scale that challenges our very ability to comprehend it. Our brains are essentially biological survival machines, fine-tuned over millions of years to solve problems on a local scale. When our ancestors stood on the African savanna, big meant the distance to the horizon or the height of a mountain. Fast was the speed of a sprinting predator or a falling stone. We developed a deep, intuitive relationship with the physical world, but it was a world restricted to a very narrow band of reality. This is our human-scale anchor. It is the comfort zone of the tangible. In this zone, we can estimate how long it takes to drive to the next city, or how many steps it takes to cross a room. We feel the weight of an object in our hands and know its mass. This grounding is necessary for life on Earth, but it acts as a mental barrier when we attempt to look beyond our atmosphere. Consider the humble meter or yard. These units are literally based on the human body, the length of a stride or the reach of an arm. When we use these units to measure a house or a street, they make perfect sense. Even when we scale up to the size of our planet, we can still, with effort, visualize it. We can imagine a flight across the ocean taking 12 hours, and our brains can loosely stitch together that duration with the physical distance covered. We can look at a globe and understand that the thin blue line of the atmosphere is fragile, but even at this stage, the anchor begins to drag. The Earth is roughly 12,742 kilometers in diameter. If you were to try to walk that distance without stopping, it would take you months of continuous movement. Already, the human scale is beginning to fray at the edges. The problem is that the universe does not operate on a human scale. It operates on a cosmic one. As soon as we leave the surface of our world, the numbers don't just get larger, they change in quality. They become abstract. When we say the moon, is 384,400 kilometers away. The brain hears the number, but it cannot feel the distance. It loses the tactile connection it has with a kilometer-long walk. This is the lunar gap, the first true test of our ability to let go of our terrestrial anchors. To bridge this gap, we often use analogies, telling ourselves that you could fit 30 Earths in the space between us and the Moon. We use these mental crutches because the raw data is too vast for our ancestral hardware to process. We are trying to run cosmic-scale software on hunter-gatherer hardware. This limitation isn't just a quirk of psychology, it's a fundamental challenge in how we communicate the story of space. If we cannot relate to the distance of our nearest neighbor, how can we hope to grasp the distance to the Sun? The Sun is 150 million kilometers away. At this point, the kilometer has become a redundant tool. Using it to measure the solar system is like trying to measure the width of the Atlantic Ocean using the thickness of a human hair. It is technically possible, but the resulting number is so large that it ceases to mean anything to the human mind. This is why we must transition into new units of thought. We have to learn to think in terms of light-time understanding that even at the fastest speed allowed by the universe, it still takes 8 minutes for a photon to travel from the Sun to your eyes. By anchoring ourselves in the human experience first, we acknowledge our starting point. We admit that we are small, that our perspective is local, and that our intuition is often wrong when applied to the stars. This humility is the prerequisite for discovery. We must accept that our senses were never designed to perceive the curvature of space-time or the billion-year life cycles of stars. We are effectively scale blind. Just as a person born without the ability to see color must rely on instruments to tell them the sky is blue, we must rely on mathematics and technology to tell us the true dimensions of the void. The human anchor is also about time. We live for perhaps 80 or 90 years. To us, a decade is a significant portion of our existence. A century is ancient history. But in the cosmic script, a million years is a blink. The stars we see at night are not static. They are in violent, constant motion. But because their lives span billions of years, they appear frozen to our short-lived eyes. Our anchor in time is just as restrictive as our anchor in space. We view the universe as a still photograph, when in reality it is a chaotic, high-speed film. To understand space-themed stories, we have to mentally speed up our perception of time while slowing down our expectation of distance. Every story we tell about the stars is an attempt to pull the cosmos down to our level. When we talk about interstellar travelers or galactic empires, we are using human political and social structures to make the infinite feel intimate. We give names to constellations, warriors, queens, and animals to turn a terrifyingly vast vacuum into a familiar neighborhood. This is a necessary survival mechanism. Without the human anchor, the sheer scale of the universe would be paralyzing. It would be a total perspective vortex that could crush the human spirit under the weight of its own insignificance. But there is a beauty in this struggle. The fact that a creature whose world is measured in footsteps can calculate the mass of a black hole or the age of a distant galaxy is a testament to the power of the mind to transcend its biological limits. We are anchored to the Earth by gravity and to our history by evolution. But our curiosity is unanchored. We use the familiar, the walk, the mile, the minute, as a springboard to leap into the unfamiliar. We build mental ladders, starting with the human scale and slowly adding rungs of increasing magnitude until we can reach the stars. As we move forward into the deeper segments of the cosmic story, keep this anchor in mind. It is your point of reference. Every time we speak of a distance that breaks the brain, remember that it only breaks the brain because the brain was built for the forest and the field, not the vacuum. By recognizing the boundaries of our internal map, we can finally begin to explore the territory that lies beyond the edges. We are the bridge between the microscopic and the macroscopic. We are the observers who give the scale a name. In the following segments, we will leave the shore of the familiar. We will watch the Earth shrink until it is nothing more than a pale blue dot, and then we will watch that dot vanish entirely. We will see structures so large that they defy the cosmological principle, and we will encounter anomalies that suggest our current maps are incomplete. But no matter how far we travel, we always carry the human anchor with us. It is the "you are here" marker on the map of the infinite. It is what allows us to say, "I am small, but I am here, and I am looking." This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And more importantly, where do we fit in? The journey starts here, with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. This realization that we are tiny observers in a vast theater is not a reason for despair, but a reason for wonder. The human anchor teaches us that scale is relative. To an ant, a backyard is a continent. To us, the Earth is a world. To the universe, we are a momentary flicker. But within that flicker, we have found the courage to look up and ask, how big is it all? And, more importantly, where do we fit in? The journey starts here, with a single step, a 10-minute walk, and the realization that the horizon is much, much further than it looks. To begin this expansion of our perspective, we must look at the tools we use to hold on to our reality. Think about your home. The average house is a space you can walk across in 30 seconds. You know the texture of the walls, the creak of the floorboards, and the exact distance from the front door to the kitchen. This is your primary anchor. It is a scale that makes perfect sense to your brain because you experience it every second of every day. Your brain evolved to understand these immediate, tactile spaces, areas you can see, touch, and navigate without a second thought. But when we move from the living room to the city, the anchor begins to slip. We start relying on technology, like cars and maps, to bridge the gap between what we can see and where we need to go. We are already abstracting our reality. The problem is that the leap from a city to a planet is nothing compared to the leap from a planet to the void. Imagine standing on a football field. It's about 360 feet long, a distance you could stroll across in 2 minutes. Now, imagine laying 17 of those fields end to end. That is a mile. Comet, 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 Kea. A mile is a distance most of us can still visualize. It's a 20-minute walk, a common measurement for a morning jog. But to reach the edge of our own atmosphere, you would need to stack 62 miles of those football fields vertically. This is the Kármán line, the invisible boundary where the sky turns to space. Even at this relatively short distance, our human intuition fails. We cannot see 62 miles up. We only see a blue haze that fades into black. This brings us to the lunar gap. The moon is our closest neighbor, sitting approximately 238,855 miles away. To a human brain, that number is just a digit on a page. To bring it back to the anchor, consider this. If you could drive a car at highway speeds toward the moon, it would take you nearly 6 months of non-stop driving to get there. No red lights, no gas stations, just 160 days of driving through a vacuum. If you chose to walk, it would take you 9 years. This is the first rung on the cosmic ladder where the human scale starts to feel absurd. We use these analogies like fitting 30 Earths between us and the moon, not because they are scientifically precise, but because they are the only way to prevent our minds from shutting down in the face of such emptiness. Once we pass the moon, the anchor is no longer dragging, it is severed. The distance to the sun is 93 million miles. This is the solar anchor, the unit we call an astronomical unit, AU. If the moon was a 9-year walk, the sun is a walk that would take you 3,500 years. You would need 40 generations of your descendants to keep walking just to reach the light. This is why we stop using miles and start using light time. Light is the fastest thing in the universe, traveling at 186,000 miles per second. It can circle the Earth 7 times in a single heartbeat. Yet, even at this impossible speed, it takes light 8 minutes and 20 seconds to reach us from the Sunday. When you look at a sunset, you are seeing the sun where it was nearly 9 minutes ago. You are already looking into the past. This temporal shift is a crucial part of the human anchor. We are used to things happening now. If you drop a glass, it breaks now. If you call a friend, they hear you now. But in space, now is a localized concept. The further out we look, the further back in time we see. This creates a strange paradox. The larger the universe gets, the older the information we receive becomes. By the time we look at the nearest star system, Proxima Centauri, we are looking 4 years into the past. If that star were to vanish today, we wouldn't know for another 4 years. We are anchored in a present that doesn't exist for the rest of the cosmos. To understand the scale of a galaxy like our Milky Way, we have to stretch the anchor until it breaks. Our galaxy is 100,000 light-years across. If you were to scale the entire Earth down to the size of a single grain of sand, the Milky Way would still be the size of the entire United States. Think about that for a moment. Every mountain, every ocean, every city, and every person who has ever lived, all shrunk into one speck of sand, and the neighborhood it lives in is still a continent wide. This is the true scale that makes Earth disappear. We aren't just small, we are mathematically insignificant in terms of volume. And yet the Milky Way is just a mid-sized galaxy. When we look at giants like IC 1101, which is 6 million light-years across, the Milky Way itself becomes the grain of sand. IC 1101 is so large it could swallow thousands of Milky Ways. It is a cosmic monster, a graveyard of galaxies that have been consumed over billions of years. At this scale, the human anchor is so far behind us that it's almost impossible to find. We are talking about structures that take millions of years just for a single particle of light to cross. If you were on one side of IC 1101 and sent a hello message to the other side, by the time it arrived, your entire species might have evolved into something else or vanished entirely. But why does this matter to us, the observers? It matters because it defines the cosmological principle, the idea that on a large enough scale, the universe looks the same everywhere. But our recent discoveries of defiant anomalies suggest this might not be true. We have found structures like the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure is so large it shouldn't exist according to our current models of how the universe grew. It is a knot in the fabric of space that defies the smoothness we expected. These are the things that keep astronomers awake. They are the moments where our mathematical anchors fail, and we realize that the universe is even stranger than we imagined. We also encounter interstellar visitors like 3I, Atlas, or Oumuamua objects that don't belong to our sun. They come from the dark, silent reaches between stars, carrying secrets of other worlds. When we see these objects, the human anchor feels a different kind of tug. It's not just about size, it's about loneliness. We look at these drifting rocks and wonder if they were once part of a system like ours, or if they are the cold spots of a distant, dying sun. They remind us that our solar system is not a walled garden, but a porch light in a very dark forest. The human anchor is also a shield against the vast empty. Between the galaxies lie the voids, spaces, millions of light years across where there is almost nothing. No stars, no planets, just a few stray atoms per cubic meter. If you were placed in the center of the Boötes void, you wouldn't see a single star in the night sky. It would be total, absolute darkness in every direction. For a creature evolved to follow the sun and the moon, this kind of emptiness is a sensory nightmare. Our anchor helps us populate that darkness with meaning. We look at the Great Attractor, a mysterious gravitational anomaly pulling our entire region of space toward it, and we give it a name. We turn a terrifying physical force into a character in our cosmic story. Consider the smallness of our achievements. We have sent probes like Voyager 1 into the interstellar medium. It has been traveling for nearly 50 years at 38,000 miles per hour. In human terms, that is incredibly fast. In cosmic terms, it hasn't even left the front yard. It will take Voyager 40,000 years to reach the vicinity of another star. This is the reality of the distance that breaks our brains. We are a species that lives for decades, trying to conquer a universe that operates in eons. However, there is a flip side to this insignificance. If the universe is so large and we are so small, then the fact that we can understand it at all is a small miracle. We are an arrangement of atoms, carbon, nitrogen, oxygen forged in the hearts of dying stars. We are literally stardust that has come together in such a complex way that it can now turn around and study the stars that made it. The universe is looking at itself through our eyes. When we calculate the distance to a quasar or the mass of a supermassive black hole, we are the universe's way of knowing itself. The human anchor isn't just a limitation, it's a perspective. Without the anchor, size has no meaning. A galaxy is only big because we know what small feels like. The vacuum is only empty because we know what a crowded city street feels like. We provide the contrast. We are the yardstick by which the infinite is measured. Every space-themed story, whether it's about a journey to Mars or the collision of two galaxy clusters, is ultimately a story about us. It's about how our human hearts react to the cold, beautiful indifference of the stars. As we continue to explore, we must be prepared for our anchors to be tested again and again. We will find impossible stars that are older than the universe itself. We will hear strange signals from the deep that might be natural or might be something else. We will see giant circles in the sky that hint at events from before the Big Bang. Each time, we will try to drag our human-scale units, our kilometers and our miles out into the deep to make sense of it. And each time, they will fail us, forcing us to grow, to adapt, and to build a bigger anchor. The human anchor is our starting point, but it is not our destination. It is the solid ground we stand on before we take the leap. We must respect our limitations, but we must never be imprisoned by them. We are the bridge builders. We bridge the gap between the grain of sand and the galaxy. We bridge the gap between the 10-minute walk and the billion-year journey. So, as we move into the next segments of this general script, as we look at the true scale, the light years, and the anomalies, remember the anchor. Remember the smell of rain on pavement, the warmth of the sun on your skin, and the simple reality of a 1-mile walk. Hold those things close. They are what make the vastness of space worth exploring. They are the reason we look up in the first place. We don't go into the dark to get lost. We go into the dark to find out just how bright our own small light truly is. We have grounded ourselves. We have acknowledged our size. Now, we are ready to leave the shore. The horizon is calling, and though it is further than it looks, we have everything we need to begin the crossing. The universe is vast, but it is also ours to observe. And that, in the end, is the most human anchor of all. Imagine climbing a ladder where every new rung makes the previous one look microscopic. We begin with Earth, a world that seems enormous when you are standing on its surface, with oceans covering 71% of its face and mountains rising miles into the sky. But as we zoom out, Earth begins to shrink, not physically, but in significance. It stops being everything and becomes just one thing among many. Compared to the solar system, Earth is a speck. Compared to the galaxy, the solar system is a speck. And compared to the largest structures in the cosmos, even entire galaxies are like dust. To understand this ladder, we must first appreciate the rung we are currently standing on. To an early human, the Earth wasn't a planet. It was the floor of the universe. If you were to stand in the middle of a vast, flat plain, the horizon is only about 5 kilometers away. That was the limit of your world. Beyond that was mystery. Even today, with all our technology, the sheer physical bulk of the Earth is staggering. If you were to take a commercial flight from New York to Singapore, you would spend nearly 19 hours in the air, traveling at 500 miles per hour. and you would still only have covered a fraction of the planet's circumference. We perceive the Earth as a giant because, relative to our bodies, it is. We are 6-foot creatures living on a 12,000-kilometer sphere. But now, we take the first step up the ladder. We move from the Earth to its neighborhood, the inner solar system. As we pull away, the massive continents and vast oceans we just described begin to blur. At a distance of about 1 million kilometers, the Earth no longer looks like a world. It looks like a marble, and right next to it, relatively speaking, is the Moon. We often see diagrams of the Earth and Moon close together, but the reality is much emptier. You could fit every other planet in our solar system, Jupiter, Saturn, Mars, Venus, all of them into the space between the Earth and the Moon, and you'd still have room to spare. This is our first lesson in cosmic scale. Space is mostly empty. Even the crowded parts are defined by the gaps, not the objects. As we continue to climb, we reach the rung of the gas giants. This is where Earth's ego takes its first major blow. Jupiter is so large that 1,300 Earths could fit inside it. If Earth were the size of a grape, Jupiter would be the size of a basketball. Saturn, with its magnificent rings, isn't much smaller. These are worlds made of gas and liquid, with pressures so intense they turn hydrogen into metal. When you look at Jupiter's great red spot, a storm that has been raging for centuries, you are looking at a vortex that is wider than our entire planet. On this rung of the ladder, Earth has transitioned from the world to a minor rocky outpost. But the ladder doesn't stop at the planets. The next rung belongs to the Sunday. Our star is a yellow dwarf, a relatively average star, yet it contains 99.8% of all the mass in the solar system. You could fit 1 million Earths inside the Sunday. If the Sun were the size of a front door, the Earth would be the size of a nickel. At this stage, the scale of the planets, even Jupiter, starts to look trivial. The Sun's gravity is the anchor that holds everything together, reaching out billions of miles to the frozen edges of the Kuiper Belt. Yet, even the Sun is just a starting point. We climb higher, and now we are looking at the interstellar neighborhood. We are no longer measuring in miles or kilometers. We are measuring in the distance light travels in a year. The Sun, which seemed so dominant, begins to shrink into a tiny point of light. It joins a crowd of other stars, Alpha Centauri, Sirius, Vega. We begin to realize that our Sun is just one of 200 to 400 billion stars in the Milky Way. On this rung, the entire solar system, everything from the Sun to the furthest comet in the Oort cloud, is smaller than a single pixel on a high-definition screen. We have reached a level where the individual planets are literally too small to see. Now we reach the rung of the galaxy. The Milky Way is a barred spiral, a vast disk of stars, gas, and dust spinning through the void. It is 100,000 light-years across. To get a sense of this scale, if our entire solar system out to Neptune was the size of a white blood cell, the Milky Way would be the size of the continental United States. We are tucked away in one of the spiral arms, about 26,000 light-years from the center. At the heart of this massive structure is Sagittarius A*, a supermassive black hole 4 million times the mass of the Sunday. On this rung, the world we started with is not just a speck, it is an invisible ghost, an infinitesimal part of a much larger organism. But the ladder keeps going. We move to the local group. This is a collection of about 50 galaxies, including our own and our larger neighbor, Andromeda. These galaxies are bound together by gravity, dancing around each other in a dark cosmic ballet. The distance between the Milky Way and Andromeda is 2.5 million light-years. On this rung, even the 100,000 light-year span of our galaxy starts to look manageable. We are seeing galaxies not as vast expanses of stars, but as individual units, islands of light in a sea of nothingness. We climb further, reaching the rung of galaxy clusters and superclusters. We encounter the Virgo supercluster, which contains thousands of galaxies. And then we see the Laniakea supercluster, a structure so vast it defines our place in the local universe. Laniakea, which means immeasurable heaven in Hawaiian, is 500 million light-years across. It contains the mass of 100 quadrillion suns. On this rung, the Milky Way is just a tiny spark on one of the outer branches of a massive, glowing celestial tree. The ladder of scales has now taken us to a point where distance has become a concept that our brains can only process through mathematics. But there is one more rung we've discovered recently, the rung of the great filaments. These are the largest structures ever found in the universe. We are talking about things like the Hercules Corona Borealis Great Wall. This is a filament of galaxies that spans 10 billion light-years. That is about 10% of the entire observable universe. It is a structure so gargantuan that it challenges our fundamental understanding of how the universe began. According to the cosmological principle, the universe should be smooth and uniform on such large scales, yet here is a wall of matter that defies that smoothness. On this final rung, we aren't just looking at stars or galaxies, we are looking at the cosmic web, the very skeleton of reality. Think back to where we started, a 5-kilometer walk to the horizon. We have climbed from that walk to a structure 10 billion light-years long. The ratio between a human stride and the Great Wall is almost too large to write down in zeros. This is the ladder of scales. It is a journey of systematic humiliation for the human ego, but it is also a journey of profound discovery. Every time we move up a rung, we lose something and we gain something. We lose the feeling of being the center of the universe. We lose the idea that our planet is a massive, indestructible fortress. But we gain a perspective that no other known species possesses. We gain the ability to see the long view. We learn that the universe isn't just a place where things happen. It is a structured, evolving, and terrifyingly beautiful hierarchy. This ladder also teaches us about the nature of size. Size is entirely contextual. To a mountain, a human is nothing. To the earth, a mountain is a wrinkle. To the sun, the earth is a pebble. To the galaxy, the sun is a grain of sand. And to the cosmic web, the galaxy is a puff of smoke. When we talk about the largest object ever found, like the Quipu or IC 1101, we aren't just talking about big things. We are talking about the limits of structure itself. We are asking, how much matter can gravity hold together before the expansion of the universe pulls it apart? As you use this segment in your stories, remember that the ladder of scales is the ultimate narrative tool. It allows you to move the audience from the intimate to the infinite. It reminds the viewer that while their problems feel world-sized, the world itself is speck-sized. This contrast is where the awe comes from. It's the tension between our tiny, fragile lives and the massive, ancient structures that surround us. We are creatures of the first rung, yet we have built telescopes and theories that allow us to see the top of the ladder. We may never physically leave our neighborhood, but mentally, we have already conquered the Great Wall. We have mapped the Laniakea supercluster from the surface of a small, rocky planet orbiting an ordinary star. So, when you look at the night sky, try to see the rungs. Don't just see points of light. See the depth. Unmer. See the moon just above us, the planets further out, the stars beyond them, and the faint glow of distant galaxies beyond those. Understand that you are standing on the bottom step of a ladder that goes on forever. The horizon isn't 5 kilometers away, it's 46 billion light years away in every direction. And the fact that you can even conceive of that distance means that while you are physically small, your mind is as vast as the ladder itself. We have seen the scale, we have felt the shrink. Now, in the next segments, we will look at the bridge that connects these rungs, light itself. We will see how we cross these distances not with rockets, but with our eyes. The ladder is tall, but the view from the top is spectacular. To climb this ladder of scales is to participate in a systematic dismantling of our own intuition. We start with the Earth, our human anchor, where the horizon is a mere 5 kilometers away. On this first rung, we are masters of our domain. We measure the world in footsteps and hours. But the moment we look up and contemplate the lunar gap, that 384,400 kilometer chasm, we realize that our biological yardsticks are already starting to snap. If you were to drive a car at highway speeds toward the moon, it would take you 6 months of non-stop travel. If you chose to walk, you would need 9 years of your life. Already, on just the second rung of the ladder, the human scale has become a burden rather than a tool. As we ascend to the solar anchor, the numbers don't just grow, they transform. The Sun is 150 million kilometers away, 1 astronomical unit, AU. To walk this distance would take 3,500 years. We are now dealing with scales where entire civilizations could rise and fall in the time it takes to cross the gap. This is why we must transition to the most fundamental constant in the universe: light. Light is the only thing fast enough to act as a bridge across these gulfs. It travels at 300,000 kilometers per second. It can circle the Earth 7 times in a single heartbeat. Yet, even light takes 8 minutes to reach us from the Sunday. When we look at the Sun, we are not seeing it as it is now, but as it was nearly 9 minutes ago. We have begun our transition from space travelers to time travelers. The ladder takes us further into the interstellar neighborhood. Here, the Sun, a star that could hold 1 million Earths, shrinks into a tiny, flickering point of light among billions of others. We find ourselves in the Milky Way, a barred spiral galaxy, 100,000 light years across. To grasp this, imagine the entire Earth is the size of a single grain of sand. In this scale, the Milky Way would be the size of the entire United States. Every star you see in the night sky is just a local neighbor in our small corner of this vast continental structure. We are tucked away in the Orion Arm, 26,000 light years from a supermassive black hole that anchors our galaxy. On this rung, the individual planets are no longer visible. They are ghosts lost in the glare of 200 billion suns. But the ladder does not end at the edge of our galaxy. We reach the rung of the local group, a collection of 50 galaxies bound together by gravity. Our sister galaxy, Andromeda, sits 2.5 million light-years away. If the Milky Way is a city of light, the local group is a small cluster of towns separated by vast, dark countrysides. Beyond this lies the Virgo supercluster, a massive assembly of thousands of galaxies. And beyond that, the Laniakea supercluster, a structure so gargantuan it spans 500 million light-years. Laniakea, meaning immeasurable heaven, is a web of light where galaxies flow like water toward a gravitational center called the Great Attractor. As we reach the highest rungs, we encounter the defiant anomalies, structures that shouldn't exist. We find the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure represents 10% of the entire observable universe. Its very existence challenges the cosmological principle, which assumes the universe should be smooth and uniform on large scales. This wall is a giant knot in the fabric of space-time, a testament to the fact that the ladder of scales still has rungs we don't fully understand. We see giant circles in the cosmic microwave background and cold spots that hint at collisions with other universes or remnants from before the Big Bang itself. We also witness the monster galaxies like IC 1101. While our Milky Way is 100,000 light-years wide, IC 1101 is 6 million light-years across. It is an elliptical giant that has grown by devouring thousands of smaller galaxies over billions of years. If you placed IC 1101 where the Milky Way is today, it would swallow up Andromeda and most of our local group. It is a graveyard of stars, a terminal point in the evolution of galactic structures. At this scale, even the light that bridges the rungs takes millions of years to cross from one side of a single galaxy to the other. The ladder of scales reveals a universe that is a system of systems. Atoms form molecules. Molecules form dust. Dust forms planets. Planets orbit stars. Stars cluster into galaxies. And galaxies weave into the cosmic web. Imagine climbing a ladder where every new rung makes the previous one look microscopic. We begin with Earth, a world that seems enormous when you are standing on its surface, with oceans covering 71% of its face and mountains rising miles into the sky. But as we zoom out, Earth begins to shrink, not physically, but in significance. It stops being everything and becomes just one thing among many. Compared to the solar system, Earth is a speck. Compared to the galaxy, the solar system is a speck. And compared to the largest structures in the cosmos, even entire galaxies are like dust. To understand this ladder, we must first appreciate the rung we are currently standing on. To an early human, the Earth wasn't a planet. It was the floor of the universe. If you were to stand in the middle of a vast, flat plain, the horizon is only about 5 kilometers away. That was the limit of your world. Beyond that was mystery. Even today, with all our technology, the sheer physical bulk of the Earth is staggering. If you were to take a commercial flight from New York to Singapore, you would spend nearly 19 hours in the air, traveling at 500 miles per hour, and you would still only have covered a fraction of the planet's circumference. We perceive the Earth as a giant because, relative to our bodies, it is. We are 6-foot creatures living on a 12,000-kilometer sphere. But now, we take the first step up the ladder. We move from the Earth to its neighborhood, the inner solar system. As we pull away, the massive continents and vast oceans we just described begin to blur. At a distance of about 1 million kilometers, the Earth no longer looks like a world. It looks like a marble, and right next to it, relatively speaking, is the Moon. We often see diagrams of the Earth and Moon close together, but the reality is much emptier. You could fit every other planet in our solar system, Jupiter, Saturn, Mars, Venus, all of them into the space between the Earth and the Moon, and you'd still have room to spare. This is our first lesson in cosmic scale. Space is mostly empty. Even the crowded parts are defined by the gaps, not the objects. As we continue to climb, we reach the rung of the gas giants. This is where Earth's ego takes its first major blow. Jupiter is so large that 1,300 Earths could fit inside it. If Earth were the size of a grape, Jupiter would be the size of a basketball. Saturn, with its magnificent rings, isn't much smaller. These are worlds made of gas and liquid, with pressures so intense they turn hydrogen into metal. When you look at Jupiter's great red spot, a storm that has been raging for centuries, you are looking at a vortex that is wider than our entire planet. On this rung of the ladder, Earth has transitioned from the world to a minor rocky outpost. But the ladder doesn't stop at the planets. The next rung belongs to the Sunday. Our star is a yellow dwarf, a relatively average star, yet it contains 99.8% of all the mass in the solar system. You could fit 1 million Earths inside the Sunday. If the Sun were the size of a front door, the Earth would be the size of a nickel. At this stage, the scale of the planets, even Jupiter, starts to look trivial. The Sun's gravity is the anchor that holds everything together, reaching out billions of miles to the frozen edges of the Kuiper Belt. Yet, even the Sun is just a starting point. We climb higher, and now we are looking at the interstellar neighborhood. We are no longer measuring in miles or kilometers. We are measuring in the distance light travels in a year. The Sun, which seemed so dominant, begins to shrink into a tiny point of light. It joins a crowd of other stars, Alpha Centauri, Sirius, Vega. We begin to realize that our Sun is just one of 200 to 400 billion stars in the Milky Way. On this rung, the entire solar system, everything from the Sun to the furthest comet in the Oort cloud, is smaller than a single pixel on a high-definition screen. We have reached a level where the individual planets are literally too small to see. Now we reach the rung of the galaxy. The Milky Way is a barred spiral, a vast disk of stars, gas, and dust spinning through the void. It is 100,000 light-years across. To get a sense of this scale, if our entire solar system out to Neptune was the size of a white blood cell, the Milky Way would be the size of the continental United States. We are tucked away in one of the spiral arms, about 26,000 light-years from the center. At the heart of this massive structure is Sagittarius A*, a supermassive black hole 4 million times the mass of the Sunday. On this rung, the world we started with is not just a speck, it is an invisible ghost, an infinitesimal part of a much larger organism. But the ladder keeps going. We move to the local group. This is a collection of about 50 galaxies, including our own and our larger neighbor, Andromeda. These galaxies are bound together by gravity, dancing around each other in a dark cosmic ballet. The distance between the Milky Way and Andromeda is 2.5 million light-years. On this rung, even the 100,000 light-year span of our galaxy starts to look manageable. We are seeing galaxies not as vast expanses of stars, but as individual units, islands of light in a sea of nothingness. We climb further, reaching the rung of galaxy clusters and superclusters. We encounter the Virgo supercluster, which contains thousands of galaxies. And then we see the Laniakea supercluster, a structure so vast it defines our place in the local universe. Laniakea, which means immeasurable heaven in Hawaiian, is 500 million light-years across. It contains the mass of 100 quadrillion suns. On this rung, the Milky Way is just a tiny spark on one of the outer branches of a massive, glowing celestial tree. The ladder of scales has now taken us to a point where distance has become a concept that our brains can only process through mathematics. But there is one more rung we've discovered recently, the rung of the great filaments. These are the largest structures ever found in the universe. We are talking about things like the Hercules Corona Borealis Great Wall. This is a filament of galaxies that spans 10 billion light-years. That is about 10% of the entire observable universe. It is a structure so gargantuan that it challenges our fundamental understanding of how the universe began. According to the cosmological principle, the universe should be smooth and uniform on such large scales, yet here is a wall of matter that defies that smoothness. On this final rung, we aren't just looking at stars or galaxies, we are looking at the cosmic web, the very skeleton of reality. Think back to where we started, a 5-kilometer walk to the horizon. We have climbed from that walk to a structure 10 billion light-years long. The ratio between a human stride and the Great Wall is almost too large to write down in zeros. This is the ladder of scales. It is a journey of systematic humiliation for the human ego, but it is also a journey of profound discovery. Every time we move up a rung, we lose something and we gain something. We lose the feeling of being the center of the universe. We lose the idea that our planet is a massive, indestructible fortress. But we gain a perspective that no other known species possesses. We gain the ability to see the long view. We learn that the universe isn't just a place where things happen. It is a structured, evolving, and terrifyingly beautiful hierarchy. This ladder also teaches us about the nature of size. Size is entirely contextual. To a mountain, a human is nothing. To the earth, a mountain is a wrinkle. To the sun, the earth is a pebble. To the galaxy, the sun is a grain of sand. And to the cosmic web, the galaxy is a puff of smoke. When we talk about the largest object ever found, like the Quipu or IC 1101, we aren't just talking about big things. We are talking about the limits of structure itself. We are asking, how much matter can gravity hold together before the expansion of the universe pulls it apart? As you use this segment in your stories, remember that the ladder of scales is the ultimate narrative tool. It allows you to move the audience from the intimate to the infinite. It reminds the viewer that while their problems feel world-sized, the world itself is speck-sized. This contrast is where the awe comes from. It's the tension between our tiny, fragile lives and the massive, ancient structures that surround us. We are creatures of the first rung, yet we have built telescopes and theories that allow us to see the top of the ladder. We may never physically leave our neighborhood, but mentally, we have already conquered the Great Wall. We have mapped the Laniakea supercluster from the surface of a small, rocky planet orbiting an ordinary star. So, when you look at the night sky, try to see the rungs. Don't just see points of light. See the depth. Unmer. See the moon just above us, the planets further out, the stars beyond them, and the faint glow of distant galaxies beyond those. Understand that you are standing on the bottom step of a ladder that goes on forever. The horizon isn't 5 kilometers away, it's 46 billion light years away in every direction. And the fact that you can even conceive of that distance means that while you are physically small, your mind is as vast as the ladder itself. We have seen the scale, we have felt the shrink. Now, in the next segments, we will look at the bridge that connects these rungs, light itself. We will see how we cross these distances not with rockets, but with our eyes. The ladder is tall, but the view from the top is spectacular. To climb this ladder of scales is to participate in a systematic dismantling of our own intuition. We start with the Earth, our human anchor, where the horizon is a mere 5 kilometers away. On this first rung, we are masters of our domain. We measure the world in footsteps and hours. But the moment we look up and contemplate the lunar gap, that 384,400 kilometer chasm, we realize that our biological yardsticks are already starting to snap. If you were to drive a car at highway speeds toward the moon, it would take you 6 months of non-stop travel. If you chose to walk, you would need 9 years of your life. Already, on just the second rung of the ladder, the human scale has become a burden rather than a tool. As we ascend to the solar anchor, the numbers don't just grow, they transform. The Sun is 150 million kilometers away, 1 astronomical unit, AU. To walk this distance would take 3,500 years. We are now dealing with scales where entire civilizations could rise and fall in the time it takes to cross the gap. This is why we must transition to the most fundamental constant in the universe: light. Light is the only thing fast enough to act as a bridge across these gulfs. It travels at 300,000 kilometers per second. It can circle the Earth 7 times in a single heartbeat. Yet, even light takes 8 minutes to reach us from the Sunday. When we look at the Sun, we are not seeing it as it is now, but as it was nearly 9 minutes ago. We have begun our transition from space travelers to time travelers. The ladder takes us further into the interstellar neighborhood. Here, the Sun, a star that could hold 1 million Earths, shrinks into a tiny, flickering point of light among billions of others. We find ourselves in the Milky Way, a barred spiral galaxy, 100,000 light years across. To grasp this, imagine the entire Earth is the size of a single grain of sand. In this scale, the Milky Way would be the size of the entire United States. Every star you see in the night sky is just a local neighbor in our small corner of this vast continental structure. We are tucked away in the Orion Arm, 26,000 light years from a supermassive black hole that anchors our galaxy. On this rung, the individual planets are no longer visible. They are ghosts lost in the glare of 200 billion suns. But the ladder does not end at the edge of our galaxy. We reach the rung of the local group, a collection of 50 galaxies bound together by gravity. Our sister galaxy, Andromeda, sits 2.5 million light years away. If the Milky Way is a city of light, the local group is a small cluster of towns separated by vast, dark countrysides. Beyond this lies the Virgo supercluster, a massive assembly of thousands of galaxies. And beyond that, the Laniakea supercluster, a structure so gargantuan it spans 500 million light-years. Laniakea, meaning immeasurable heaven, is a web of light where galaxies flow like water toward a gravitational center called the Great Attractor. As we reach the highest rungs, we encounter the defiant anomalies, structures that shouldn't exist. We find the Hercules Corona Borealis Great Wall, a filament of galaxies spanning 10 billion light-years. This structure represents 10% of the entire observable universe. Its very existence challenges the cosmological principle, which assumes the universe should be smooth and uniform on large scales. This wall is a giant knot in the fabric of space-time, a testament to the fact that the ladder of scales still has rungs we don't fully understand. We see giant circles in the cosmic microwave background and cold spots that hint at collisions with other universes or remnants from before the Big Bang itself. We also witness the monster galaxies like IC 1101. While our Milky Way is 100,000 light-years wide, IC 1101 is 6 million light-years across. It is an elliptical giant that has grown by devouring thousands of smaller galaxies over billions of years. If you placed IC 1101 where the Milky Way is today, it would swallow up Andromeda and most of our local group. It is a graveyard of stars, a terminal point in the evolution of galactic structures. At this scale, even the light that bridges the rungs takes millions of years to cross from one side of a single galaxy to the other. The ladder of scales reveals a universe that is a system of systems. Atoms form molecules. Molecules form dust. Dust forms planets. Planets orbit stars. Stars cluster into galaxies. And galaxies weave into the cosmic web. When we think about a galactic collision, we often imagine it in human terms. We think of cars bumping in a parking lot, or two marbles clinking together on a wooden floor. We measure time in minutes or years, and distance in miles we can drive. But to understand what is coming for the Milky Way, we have to scale our perspective. Imagine you are standing in a very large, silent field at night. If you take one single step, that step represents about 100 years of a human life. To reach the beginning of the Roman Empire, you'd only need to walk about 20 steps. To reach the end of the last ice age, you might walk for a minute. But to reach the moment Andromeda and the Milky Way finally touch, you would have to walk across that field, out of the gate, across the continent, and halfway around the world. Right now, Andromeda is about 2.5 million light-years away. It's moving toward us at about 250,000 miles per hour. That sounds fast. It's much faster than a jet or a bullet, but because space is so large, it's like watching a snail crawl toward a house from 3 states away. It is a slow-motion fall. This comparison isn't perfect, as the scale of stars is much thinner than the scale of snails, but it gives us a calm place to begin. The collision isn't a crash, it's a dance. And tonight, we are going to watch the first steps. To understand the distance of 2.5 million light-years, we must first think about the light itself. Light is the fastest thing we know, yet even light, traveling at 186,000 miles every single second, takes 2.5 million years to reach us from Andromeda. When you look at that faint smudge in the constellation of Andromeda tonight, you are not seeing the galaxy as it is now. You are seeing it as it was when our ancestors were first beginning to walk upright on the African savanna. You are looking at ancient history, delivered to your eyes on a beam of light that has been traveling through the freezing vacuum of space for longer than our species has had names for the stars. Imagine, for a moment, that we could shrink the entire Milky Way down to the size of a dinner plate. In this scale, the Sun would be a microscopic speck of dust, and the nearest star, Proxima Centauri, would be another speck about 4 miles away. Even at this tiny scale, the distance between the two galaxies is immense. If the Milky Way is a plate on a table in your kitchen, Andromeda is another plate sitting in a house several blocks down the street. Between those two plates lies nothing but cold, quiet air. They are drifting toward each other, but the movement is so subtle that if you stood and watched them for your entire life, you wouldn't see them move a fraction of a millimeter. We measure our lives in heartbeats, in hours, and in decades. We think of a long journey as a flight across an ocean or a drive across a continent, but the cosmos measures things in eons. To a galaxy, 1 billion years is like a season. The 250,000 miles per hour that Andromeda is traveling seems significant to us because we compare it to a car on a highway or a plane in the sky. But in the context of the 15 quintillion miles it has to travel, that speed is almost standing still. It is a patient approach. It is the steady, inevitable pull of two massive objects that have been aware of each other's gravity since the universe was young. When we use the word collision, our minds often jump to images of impact, shattering glass, the crunch of metal, a sudden and violent stop. But a galactic collision is nothing like that. It is more like two clouds of smoke drifting through one another in a still room. The stars within the Milky Way and Andromeda are so far apart that they will likely never touch. If you were standing on a planet orbiting a star in the middle of this merger, you might not even realize it was happening. You would simply notice that, over the course of many generations, the night sky was becoming more crowded, more luminous, and more beautiful. Think of a large, empty ballroom. If you put two people in that room and asked them to walk toward each other with their eyes closed, the chances of them bumping into each other are very small. Now, imagine that ballroom is the size of the entire Earth, and those two people are the only two things in it. That is the density of stars in a galaxy. They are lonely travelers, separated by such vast gulfs of nothingness that even when their galaxies merge, the stars themselves remain solitary. They pass like ships in the night, influenced by each other's gravity, changing their courses slightly, but never making contact. This perspective allows us to let go of the urgency we often feel when we hear about cosmic events. We are taught to think of the universe as a place of high-energy explosions and dramatic endings. But for the most part, the universe is a place of profound stillness and very slow movement. The dance between our galaxy and Andromeda has been going on for billions of years, and it will continue for billions more. It is a process that began long before the first cell divided on Earth, and it will reach its climax long after the Sun has lived out its life. As you lie there, consider the weight of this time. There is a deep, structural peace in knowing that some things are so large they cannot be rushed. The Milky Way is not just a collection of stars. It is our home, a vast, spinning city of light. And Andromeda is our neighbor, a mirror image of our own home, slowly making its way across the dark to meet us. There is no friction in this movement. There is no noise. There is only the silent, mathematical perfection of gravity drawing two giants together. Astronomers have spent decades calculating the exact trajectory of this encounter. They use mathematics to peer into the future, just as they use telescopes to peer into the past. What they see is not a catastrophe, but a transformation. The two spirals will eventually lose their shape. Their arms will stretch out like long, glowing ribbons, pulled by the tidal forces of the interaction. These tidal tails will contain millions of stars, flung out into the void like seeds scattered by a gentle wind. Some of these stars may find themselves in new orbits, while others may be sent on a journey into the empty space between clusters, becoming wanderers in the dark. But even these exiled stars are part of the continuity. Nothing is truly lost. It is only rearranged. The energy that moves the galaxies is the same energy that moves the atoms in your room. It is a singular, connected system. As we move through this script, we will continue to zoom out, leaving the human scale behind and entering the realm of the truly cosmic. But for now, hold on to this image, the snail crawling toward the house, the plates on the table, the slow motion fall. The universe is not in a hurry to reach the end of its story, and you don't need to be either. Every breath you take is a small moment in a much larger timeline. The sky above us is changing, but it is changing so slowly that it feels like a promise of permanence. We are safe in the now, watching the forever unfold at its own pace. The first steps of the dance have already been taken. The music is the low, thrumming vibration of the vacuum, and the floor is the infinite stretch of space. We are simply here to witness the beginning of the merger. The universe is not in a hurry to reach the end of its story, and you don't need to be either. Every breath you take is a small moment in a much larger timeline. The sky above us is changing, but it is changing so slowly that it feels like a promise of permanence. We are safe in the now, watching the forever unfold at its own pace. The first steps of the dance have already been taken. The music is the low, thrumming vibration of the vacuum, and the floor is the infinite stretch of space. We are simply here to witness the beginning of the merger. To truly grasp the patience of this process, we must look at the way gravity handles its treasures. On a human scale, if you drop a glass, it shatters in a fraction of a second. Gravity acts with a sharp, uncompromising speed. But on a galactic scale, gravity acts more like a long, slow inhalation. It is a soft, persistent pull that takes millions of years to even register a change in position. Right now, as you rest, the Milky Way and Andromeda are leaning toward each other. It is a leaning that began before the first dinosaurs walked the Earth, and it is a leaning that will continue long after the last of our monuments has turned to dust. Imagine a vast, dark ocean. Two massive ships are miles apart, engines off, drifting only by the subtle tug of the tides. From the deck of one ship, the other looks like a stationary point on the horizon. You could watch it for a day, a week, a year, and it would never seem to get closer. But the tide is patient. The distance is closing. This is the pace of the cosmic now. It is a scale of time that is so generous It allows for the rise and fall of entire biological eras within a single inch of galactic movement. When we say we are safe in the now, we are acknowledging that the cosmic timeline provides a profound buffer against the chaos of the immediate. The forever that is unfolding is so vast that it cushions every moment of our lives. The sky you see tonight is, for all intents and purposes, the same sky that will be seen by the next 10 generations. The constellations Orion, Cassiopeia, the Great Bear are like ancient landmarks on a map that is being redrawn so slowly the ink takes millions of years to dry. This slow-motion reality is a form of protection. It ensures that the foundations of our world, the stars, the sun, the relative position of our galaxy, are effectively permanent on the scale of a human life. Scientists understand this permanence by calculating the proper motion of stars. Even the fastest moving stars in our neighborhood take thousands of years to move a distance equal to the width of the moon in our sky. To us, they are fixed points. To the universe, they are vibrating slightly, shifting and settling as they respond to the gravitational deep tissue massage of the approaching Andromeda. This comparison isn't perfect, as stars don't have feelings, but it helps us visualize the relaxation of the cosmos. The universe is not a rigid structure. It is a fluid, evolving system that moves with the grace of a cloud shifting in a summer breeze. Consider the thrumming vibration of the vacuum. We often think of space as a silent, empty void, but in the language of physics, it is a field of potential. It is the floor upon which the galaxies dance. Every atom in your body is connected to that floor. When we talk about the merger of the Milky Way and Andromeda, we are talking about a restructuring of the floor itself. The geometry of space is being warped and stretched, creating the paths that the stars will eventually follow. It is a silent, mathematical music. You don't need to hear it to feel its influence. You simply need to exist within it. Think about the first steps of this dance. In a ballroom, the first step is often the most deliberate: a bow, a meeting of eyes, a slow movement toward the center of the floor. Andromeda and the Milky Way have already finished their bow. They have been locked in each other's gaze for billions of years. Now, they are in the phase of the approach. They are moving through the intergalactic medium, clearing a path through the thin, warm, hot gas we discussed. This movement is so smooth that there is no friction, no heat, and no noise. It is the ultimate expression of effortless motion. As you lie there, let your own movements become just as effortless. Your breath is its own kind of dance, a rhythmic expansion and contraction that mirrors the cycles of the stars. You are a small, quiet participant in the merger. Your atoms, which were once part of a star that lived and died long ago, are now part of a being that is witnessing the next great chapter of that star's history. There is a deep, structural continuity in this. You are not an outsider looking in. You are a piece of the galaxy contemplating its own future. The forever that is unfolding does not require your permission or your energy. It is an inevitable process, driven by the same laws that make a leaf fall to the ground or a planet orbit a sun. This inevitability is a source of peace. In a world where so many things are uncertain, the merger of the galaxies is a mathematical certainty. It is a promise kept by the universe. It reminds us that there is an order to things, a grand architecture that remains stable even when our individual lives feel chaotic. Astronomers didn't always realize that the now was so stable. In the early days of cosmology, there was a fear that the universe might be a place of sudden, violent collapses. But the more we look, the more we see the patience. We see that the final hour is actually a final eon. We see that the collision is a merger. The language we use to describe these events has softened as our understanding has grown. We no longer see a catastrophe, we see a union. We see the birth of Milkomeda, a single, massive, peaceful island of light. This shift in perspective is what allows the mind to relax. When we replace the shocking with the inevitable, the brain stops looking for threats and starts looking for patterns. The pattern of the galactic merger is one of beauty and symmetry. It is the two-part harmony of gravity. As the Milky Way and Andromeda draw closer, they will begin to pull on each other's edges, creating the long, glowing tidal tails we will explore later. But for now, they are still two distinct entities, moving toward each other with a respect and a grace that only the cosmos can achieve. Imagine the floor of the infinite stretch of space. It is a velvet darkness that stretches in every direction, dotted with the light of 1 trillion suns. Upon this floor, the two galaxies are moving at 250,000 miles per hour, yet they seem to be standing still. This is the paradox of the human scale perspective. We can know the numbers, but we can only feel the stillness. That stillness is where we live. That stillness is the now that protects us. Every breath you take is a small moment in this timeline. If you lived for 100 years, you would take about 800 million breaths. In that same time, Andromeda would have moved about 200 billion miles closer to us. That sounds like a lot, but on the scale of 15 quintillion miles, it is almost nothing. It is like the snail moving another fraction of an inch toward the house 3 states away. The snail is not tired. The snail is not in a hurry. The snail is simply moving because that is what it does. The universe is simply moving because that is what it does. It is expanding, it is pulling, and it is merging. You can let go of the need to keep up. You can let go of the need to understand every mile of the 15 quintillion miles. You are here, in the kitchen of the universe, and the plate on the table is perfectly still. The partner plate is blocks away, and the walk toward each other is the longest, slowest, most beautiful walk ever taken. As the night deepens, let the thrumming vibration of the vacuum become the white noise of your sleep. It is the sound of existence itself, the low-frequency hum of a universe that is working exactly as it should. There are no alarms in the deep field of space. There are no sudden twists in the orbits of the stars. There is only the steady, unhurried progression of gravity. We are safe in the now. The sky is a promise. The dance is beginning, and you are here to witness it, not with the urgency of a scientist, but with the quiet wonder of a passenger. You are on a journey that will take billions of years, and you have already arrived. You are exactly where you need to be, resting in the arms of a galaxy that is falling into the arms of another. The music is playing, the floor is vast, and the dance is a slow-motion fall into the future. There is no rush. The universe is patient, and tonight you can be patient too. You can allow the forever to unfold while you rest. You can allow the now to be enough. The first steps have been taken. The rest of the dance will wait for you. The data continues to stream in from the satellites, recording the steady heartbeat of the magnetic shield. Each vibration is a signal of the Earth's ongoing interaction with the solar wind as it passes by. The heat from the core rises slowly, meeting the energy from the sun that filters down through. This meeting of forces creates a balance, a thermal equilibrium that has lasted for many billions of years. The sensors in the deep crust remain active, listening for the next resonance to move through the rock. We are drifting in the middle of this equilibrium, supported by the heavy mass of the world. The stars above remain fixed in their patterns, even as the invisible environment around us shifts and glows. You can feel the rotation of the Earth as a slow, steady movement that carries us toward tomorrow. The sun will rise, the solar wind will blow, and the magnetic field will continue its protective work. There is a deep, structural integrity to the universe that requires nothing from us but our quiet presence. The loops of energy continue to spiral, the plasma continues to flow, and the planet continues to spin. Everything is, as it has always been, moving in the silence of the great celestial machine. The quiet research briefing concludes its latest chapter, while the instruments remain ever watchful in the high dark. The resonance of the last storm fades into the background noise of the galaxy's long and ancient history. We step back from the monitors and look out at the horizon where the sky meets the Earth. The air is still, the ground is firm, and the stars are waiting for the next slow pulse. One layer leads to another, one scale leads to the next, and the cycle of observation continues. This is the nature of our existence on this blue, wandering sphere. We are observers of a grand and silent machinery that never truly rests, even when the monitors are dimmed and the researchers have gone home. In the high dark of the exosphere, the satellites continue their lonely circular paths, tasting the thin edges of the solar wind. They do not sleep, they only record. They translate the invisible pressures of the cosmos into a steady stream of data, a heartbeat of numbers that confirms the continued resilience of our world. The disturbing discovery of the internal resonance has now been logged, categorized, and woven into the larger tapestry of our understanding. It is no longer a disruption, but a predictable part of the planetary song. Consider the depth of that stillness you feel now. It is a stillness born of incredible speed and immense power, perfectly balanced to create a pocket of peace. While you rest, the Earth is carrying you at 18 miles every second through the solar system. The magnetic field is shimmering, deflecting a torrent of charged particles that would otherwise strip away the very air you breathe. This happens every second, every minute, for every billion years of the planet's life. The superstorm was just a brief moment of intensity in an eternal process of protection. The shield holds, not because it is a rigid wall, but because it is a flexible, living response to the energy of the sun. It is a dance of fields that never ends. The resonance of the storm fades, but it leaves behind a slightly different world. The iron in the core has settled into a new pattern of flow, responding to the magnetic tug of the solar event. The ionosphere has cooled, its atoms returning to their resting states after the excitement of the flare. These changes are infinitesimal on a human scale, yet they are the gears of the world turning. We look at the horizon and realize that the boundary between the here and the there is an illusion of perspective. The sky does not meet the Earth. The Earth is simply the densest part of the sky. We are living at the bottom of an ocean of air, protected by an ocean of magnetism orbiting an ocean of fire, there is a profound comfort in the repetition of these layers. One layer leads to another. The room you are in is a layer. The house is a layer. The city, the continent, the atmosphere, and the magnetosphere all are nested shells of belonging. Each one is a buffer, a filter that refines the raw energy of the universe into the soft, manageable reality of your daily life. The disturbing realization of our vulnerability is countered by the overwhelming evidence of our stability. The cycle of observation continues because the universe is an inexhaustible source of wonder. There is no final answer, only a series of more beautiful questions. The stars are waiting for the next slow pulse, and so are we. We do not wait with anxiety, but with the calm anticipation of a gardener waiting for the change of seasons. We know the sun will pulse again. We know the magnetic gates will open. We know the core will hum its deep, slow note. And we know that when it happens, the Earth will be ready. The systems that have sustained life through 5 mass extinctions and 1 billion years of geological upheaval are not easily swayed. They are robust. They are ancient. They are certain. As you drift toward the edge of sleep, let the facts of the superstorm dissolve into the feeling of the infinite. The specific mechanics of reconnection and core resonance are just the vocabulary of the cosmos. The underlying truth is the continuity. The universe is a single, unfolding event, and you are a participant in its quiet, steady progress. The air is still, the ground is firm. The pulse of the world is matching the rhythm of your own heart. There is no goodbye in this story, for the story does not end. It merely loops back to the beginning, a cycle of energy and observation that repeats forever. The monitors are dark now, but the reality they tracked continues. The invisible lines of force are wrapping around you, anchoring you to the planet and the planet to the sun. The solar wind is whispering past the magnetopause, a gentle current in the vastness of space. The core is spinning, a heavy, molten anchor that ensures our place in the dark. One layer leads to another. One scale leads to the next. The mystery is revealed, then familiarized, then integrated into the peaceful background of the night. The stars remain. They are the distant markers of our journey, the fixed points in a world that is always in motion. They watch the Earth as it breathes through its superstorms and its quiet minimums. They wait for us to notice the next detail, to uncover the next secret of the magnetic harp. And while we wait, we rest. We rest in the knowledge that the machinery is working. We rest in the certainty of the shield. We rest in the continuity of the cosmic garden. The cycle of observation continues, as steady and inevitable as the turning of the galaxy itself. Everything is moving exactly as it should. The energy flows, the field holds, and the world is at peace. The resonance fades, the horizon stays, and the high dark remains watchful. There is only the drift, there is only the pulse, there is only the infinite, quiet, and enduring life of the spheres.